بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome everybody in a new session in our program School Online. Today inshallah we will continue our lessons in physics. Our lesson today, the last lesson in chapter 1, Kirchhoff law. Okay, inshallah by the end of that session inshallah we will cover many items, such as inshallah we will define what's the meaning of Kirchhoff law, define first Kirchhoff law, Kirchhoff second law. We will know the mathematical formula of each one, and also we will solve many problems related to Kirchhoff law. Okay, let's start our lesson. What about our objectives today? By the end of that session, inshallah, we will define Kirchhoff first law, and also we will define Kirchhoff second law, and we will solve some questions and problems related to our lesson. Kirchhoff first law. What's meant by Kirchhoff first law? Kirchhoff first law states that at any node or junction in electric circuit, the sum of entering current equal the sum of leaving current. Again, Kirchhoff first law states that what's the definition of first law, Kirchhoff first law. At any node or junction, the sum of entering current equal the sum of leaving current. The mathematical formula. Very important question in the last exam. He asked about the formula of each equation. If he asked you what's the mathematical formula of Kirchhoff first law, you have write as the following: In, I mean the current enter the node, equal I what? I out. In equal I out. In means the current enter to the point or to the node equal the current leaving, or you can say sigma I equals 0, the algebraic summation of current at any node equal 0. Okay. Example. Use the opposite figure to calculate I5, where he gave you the values of I1, I2, I3, and I4. Okay, let's start. Okay. Example 1. As shown, use the opposite figure to calculate I1, I5, where I1 here equals 3, I2 equals 8, I3 equals 6, I4 equals 7. Here 3 ampere, I2 equals 8 ampere, I3 equals what? 6 ampere, I4 equals 7 ampere, I5 the unknown one. The most important part in our lesson today, Kirchhoff first law, indicates the node. That's the junction. Junction, as we said before, the point at which the current meets or the current splits. At that node, you have to indicate which current entered to the node, which current out from the node. Okay, let's indicate that at that node I1 enter, I5 enter. What about I4? Enter. Okay, I1, I5 and I4 enter to that node, while I2 and I3 leave outside from the node. By applying the Kirchhoff first law, I enter equal I out equal. Here in the left side, you have to put the current that enter to the node, I1, I5 and I4. يبقى I1 plus I4 plus I5. The right side, I out. According to the figure, I2 and I3 outside from the node. يبقى here I2 plus I3. Substitute. By substituting the values, I1 equals 3. يبقى here 3. I4 what? 7. I5 unknown. I2 equal what? 8. I3 equals 6. By calculation we will get I5 will be what? 4 ampere. It's too easy, inshallah. Okay, again, at any node the entering current must equal the leaving current. Pay attention with me. Let's conclude what we said. At any node, according to Kirchhoff first law, states that at any node the entering current, the current that enter to the node equals the current that leave the node. Pay attention. According to our previous lessons, what's the meaning of junction or node? Junction or node, the point at which the current meets, the branches meet. Okay, again, junction, what's the meaning of junction? Junction, the point at which what? Huh? Yes, the current at which the branches meet. The current meet and splits. There are some current enter to the node, another kinds of leaving the node. The current that enter to the node equals the current that leaves the node. Okay, let's continue our problems to the second problem. Okay, second one. Look at the opposite figure. Consists of many components. There are I1 and that splits into 31 milliampere to the first branch and 20 milliampere to the second branch. Okay, 31 continue its path until it reach that point. It will divide it into two branches. One branch to component X, 22 milliampere, and the other branch I2. Then 20 milliampere meet with I2, continue to the component of 5 ohm. Okay, according to the example, using the figure, determine the magnitude of the current I1, I2 and I3, then the potential difference across the resistance 5 ohm. Let's solve that problem. According to the problem, what about that node? Yes, I1 enter, and the current 31 milliampere outside and 20 outside. So we can calculate I1 equal what? 31 plus 30 equal 61 milliampere. يبقى at any node the current that enter equal the current that leave. Current in equal current out. Pay attention about the arrows. Okay, let's continue. What about that node? 31 milliampere enter and I2 out and 22 out. So we can calculate I2. How we calculate I2? Yeah, 31 milliampere enter to that node equal I2 outside from the node plus 22. At that node 31 enter and I2 out, 22 out according to the arrow. Pay attention about the arrow. So current enter equal current out. 31 equal I2 plus 21. We can calculate now I2. I2 equal 31 minus 21 equal 9 milliampere. يبقى I2 here 9 milliampere. What about that node? At that node 20 milliampere enter, I2 enter, I3 out. So we can calculate I3. How we calculate I3? I3 out equal 2 and 20. I3 equal what? I2 plus, yeah, I2 plus 20 milliampere. Substitute. I2 equal from the previous 9 plus 20 equal 29 milliampere. يبقى here I3 equal 29 milliampere. Again, I1 equal 31 plus 20. 31 plus 20, here 20 again, excuse me, 20 here, يبقى 51. Okay, 31 plus 20 equal 51. 31 comes to that node, it will split into two sections, I2 and 22. So we can calculate 31 equal I2 plus 22, so I2 equal 9. يبقى here 29, 9 milliampere, and 20 from here, 20 plus I2 equal 29. يبقى I3 here equal 29 milliampere. يبقى now we calculated the all unknown resistance I1, I2 and I3. 51, 9 and 29 milliampere. What next? He wants then the potential difference across the resistance 5 ohm. The resistance 5 ohm, passing through it the current I3. According to our previous lessons, the potential difference, any potential difference, equal I times R. So I here equal 29. But pay attention, you have to convert it into ampere by multiplying 10 to the power negative 3. Then times the value of the resistance itself, 5. By calculation, we can get now the potential difference across the resistance. Okay, at any node, current enter equal current out, I1 equal 31 plus 20 equal 51, I1 51. يبقى I1 51. Okay, at that node 31 enter divided into I2 and the 22, so I2 equal 9, I2 equal 9. At the last node here, I2 meet with 20, enter here and enter, and I3 out, so we can say I3 equal I2 plus 20. Okay, I3 equal I2, 9 plus 20 يبقى 29. I3 equal 29. Okay, he wants I1, I2, I3. We calculate it and then the potential difference. Next. Okay, it's too easy inshallah. Again, let's conclude what we studied now. Kirchhoff's first law, he states that at any node, the current that enter to the node equals the current that outside the node. But pay attention, you have to indicate where is the nodes around the circuit. At any node, indicate which current enter, indicate which current out, just put equal at the middle of the line. And the left side, suppose you will write the current enter to the node, and the right side the current that outside the node, just calculate, then calculate. Yani just put equal in the middle, here put the current enter, here put the current equivalent, the current that leaves the node, then calculate your, continue your calculation. Okay, it's too easy inshallah. Kirchhoff's first law. What about Kirchhoff's second law? Let's continue. Kirchhoff's second law. According to Kirchhoff's second law, at any closed circuit or loop, the sum of electromotive force equal the sum of the electromotive force equal the sum of potential difference across the resistance. Again, at any node or at any closed circuit, the sum of electromotive force equal the sum of potential difference. What about the mathematical formula of Kirchhoff's second law? Very important question in the final exam. Each year he asked about write the mathematical formula of some equations. Okay, if he asked you write the mathematical formula of Kirchhoff's second law, you have to write the following. The mathematical formula of Kirchhoff's second law: sigma VB equal sigma IR. What's the meaning of sigma VB? Sigma VB, let's continue. Sigma VB, okay, sigma VB means the algebraic summation of the, as you know, any electric circuit consists of some battery and some electric resistance passing through them current. According to Kirchhoff's second law, sigma VB equals sigma IR. Sigma VB equals sigma IR. Let's explain each side. The left side, sigma VB. Sigma VB means the sum of the electromotive force of the battery. Okay? Suppose the summation of the electromotive force, the algebraic summation of the electromotive force of the battery may be 100 volt. Okay, the potential difference across the resistance around the same circuit must be 100 volt. Again, suppose the value of the algebraic summation of the electromotive force of the battery around the circuit, around the loop, equal 100 volt. The potential difference across or drop around the resistance across the battery, the same circuit, must be 100 volts. And inshallah, by solving some question, we will show that. Okay? Let's show some question. Kirchhoff's second law. Example number 1. Look at the figure first. Our circuit consists of, as shown, how many battery? 2 batteries. The battery to right, 1.5 volt. What about the battery to left? 4.5 volt. Okay? How many resistance? 2 resistance. The resistance up, the potential difference across it, V, unknown. The potential, the resistance down, its potential difference equal 0.2 volt. Again, our loop now consists of 2 batteries and 2 resistors. The battery to right, 1.5 volt. The battery to left, 4.5 volt. And 2 resistors. One up, its potential difference V, and one down, its potential difference 0.2. He wants what? Use Kirchhoff's second law or law to determine the potential difference V. All components are known except V. So he wants to determine the potential difference V. Okay? Yeah. Let's continue. According to the previous circuit, there are 4 components throughout the loop. 4 components، 4 أشياء. يعني في 4 حاجات حوالين خلال اللوب بتاعنا. كام؟ 2 باتري اللي في اليمين واللي في الشمال، واحدة منهم 1.5 والتانية 4.5، وفي 2 ريزيستورز يعني مقاومتين، واحدة فوق البوتنشال ديفرنس بتاعها V وواحدة تحت البوتنشال ديفرنس بتاعها 0.2. يبقى أنا عندي سيركت كلوز سيركت أو لوب، LOOP معناها لوب يعني كلوز سيركت. هو طالب ايه؟ طالب البوتنشال ديفرنس هنا، ولو لاحظنا ولما نرجع للمسألة دلوقتي وهنحلها هنلاقي كله نون ما عدا دي. ازاي بقى؟ باستخدام كيرشوف سكند لو نعرف البوتنشال ديفرنس في الكومبوننت ده او في الريزيستورز ده. اوكي؟ قبل ما هطبق مع بعض، قبل ما هنعمل ابلاينج لكيرشوف سكند لو، لازم عندنا شوية قواعد رولز لازم نتبعها، او خطوات مهمة جدا لازم نكون عارفينها قبل ما نطبق كيرشوف سكند لو. ايه هي؟ مهمة جدا الخطوات دي. اهم حاجة لازم نحطها في اعتبارنا عشان لما نيجي نكون الايكويشن كويس لازم في حاجة اسمها الساينس. ما معنى كلمة ساينس؟ البوزيتيف والنيجاتيف اللي هي الاشارات. ممكن يبقى الفاليو اللي موجوده عندي البوتنشال الفي بي مثلا الالكتروموتيف فورس ممكن تبقى اوريدي هو هيديها لي بوزيتيف دايما 1.5 والثانيه 4.5، دايما لازم يديها لي بوزيتيف فاليوز. ولكن ممكن اثناء السبستيتيوشن زي ما هنتعلم دلوقتي بعض الفاليوز دي تبقى بوزيتيف، بعض الفاليوز دي تبقى نيجاتيف according to قواعد معينه، حسب قواعد معينه. يلا بينا نعرفها دلوقتي. يلا معايا كده اعلمكم ازاي دي اهم خطوه في كيرشوف التاني تحديدا. كيرشوف سكند لو كتير جدا الطلاب بيغلطوا فيها حته الساينس، الاشارات بتاعت الفي بي وبتاعت الاي ار. فاهم من تكوين المعادله لازم نعرف ازاي بنعمل الساينس الاشارات. يلا بينا نتعلمها. يلا. بيبقى انا عندي كلوز سيركت. القصه كده يا جماعه، بيبقى عندي كلوزد سيركت. الكلوزد سيركت دي فيها باتري 0.5 وفيها الناحيه الثانيه باتري كمان 4 فولت. يبقى في باتري على اليمين وباتري على الشمال حسب الدياجرام السيركت. وفي هنا ريزيستنس وفي هنا ريزيستنس. اللي فوق البوتنشال ديفرنس بتاعها في واللي تحت البوتنشال ديفرنس بتاعها 0.2. الكلام ده حسب السيركت. اول حاجه لازم نعملها بعد بسم الله الرحمن الرحيم في المساله، لو هو مش مديها لي بس غالبا بيديها لي، يعني كل الاكزامبلز المحلوله اللي في الاستيودنت بوك بتاعنا بتاع المينستري بوك دايما بيعمل لي اللوب ده كده جوه. حتى في الفاينل اكزام السنه اللي فاتت دايما بيحب يحطه تسهيلا للطالب، ولو ما كانش عاملها اعمل له زيه كده، اعملها كلوك وايز، اعملها انتي كلوك وايز، مش هتفرق وات ايفر. المهم اول خطوه اتاكد ان ده موجود كده، اللوب ده، الدوران ده. ايه ميزه الدوران ده او اهميه هذا الدوران؟ ده يعتبر الريفرنس بتاعي بتاع الساين حسب النحو ده. طيب باجي اعمل ايه كمان يا حبايبي؟ بص، اللوب ده هنا المفروض اقول كده سيجما في بي ايكوال سيجما اي ار. ده كيرشوف سكند لو. في الطرف الشمال الليفت سايد ده بنحط الفاليوز بتاعت الفي بيز. هنا عندي 4.5 وهنا عندي 0.5. ايه الجمال ده؟ تعالوا بقى نشوف بنحط الساينس ازاي. لما اجي عند ال 4.5 تعالوا بص انا بقولها ازاي. يا 4.5 يا ترى ايه الساين بتاعتي، بوزيتيف ولا نيجاتيف؟ تقول لي ايه؟ اسك ذا لوب. اروح لللوب اقول له يا لوب هي الساين بتاع دي ازاي؟ بصوا بقى القاعده بتقول كده، اللوب وهو معدي جنب الباتري دي معدي منين؟ معدي من النيجاتيف ورايح لفين؟ للبوزيتيف. يعني معدي كده. القاعده بتقول لي اذا كان اللوب اللي هو مديهولي ده اما هو رسمهولي او انا رسمته بنفسي، مش هتفرق، اعتبره خلاص اترسم. اذا كان اللوب وهو بيلف معدي جنب الباتري من النيجاتيف للبوزيتيف يبقى على طول الفاليو دي تبقى بالبوزيتيف. من النيجاتيف للبوزيتيف. طبعا كلنا عارفين على جنب كده اللاين الطويل هو البوزيتيف واللاين القصير ده هو النيجاتيف. اتكلم يا اوكي. يبقى دايما زي ما احنا اوكي زي ما احنا قلنا كده دايما اللوب وهو معدي من النيجاتيف للبوزيتيف يبقى الفاليو دي تبقى بوزيتيف. واضح؟ تمام. طيب يلا نروح بقى للي هناك. اللوب كده وهو معدي جاي اهو، يلا نكمل مع اللوب. ماشي اهو، اللوب دايما ماشي زي ما احنا راسمين كلوك وايز اهو. اهم حته اهي الجزء ده يا حبايبي، وهو معدي جنب الباتري معدي منين بقى المره دي؟ من البوزيتيف للنيجاتيف. من البوزيتيف للنيجاتيف. يبقى اللوب وهو معدي جنب الباتري من البوزيتيف للنيجاتيف يبقى دايما بحط الاشاره، بنضع الساين الاخيره اللي هو انتهى عندها من البوزيتيف للنيجاتيف يبقى نحط نيجاتيف. يبقى كده الترم ده اتكون كامل. يبقى الخطوه الاولى بنحط الفاليوز اهي، حطينا الفاليوز. بعد كده اهم خطوه بنحط الساينس. الساينس يعني الاشارات بوزيتيف ولا نيجاتيف. قلنا ايه؟ لو اللوب معدي من النيجاتيف للبوزيتيف يبقى نحط بوزيتيف. بنحط دايما الاخير من اللي انتهى عنده من النيجاتيف للبوزيتيف، نهيت ببوزيتيف يبقى احط بوزيتيف. وبعدين بيكمل وهو معدي وصل لده. لما وصل معدي جنبه منين؟ من البوزيتيف للنيجاتيف يبقى نحط نيجاتيف. ده بالنسبه لاشارات الفي بي. طب ازاي بقى نحط اشارات الاي ار؟ الاول الخطوات. الاي ار اللي هي المقصود بيها البوتنشال ديفرنس اللي موجوده في السيركت. المقصود بيها البوتنشال ديفرنس حسب السيركت اللي قصادي دي فيها كام بوتنشال ديفرنس؟ فيها منطقتين، اللي فوق اسمها في واللي تحت اسمها 0.2 كفاليو. طب ازاي احط الساين؟ الساين هنا بيحتاج مني اعمل حاجه، لازم يكون موجود كارنت في السيركت. لو مش موجود زي ما انا راسم كده مش موجود، اعمله بشكل راندم، وهو غالبا ممكن يديهولي زي ما انا بعمله كده. يعني اذا مديهولي زي خلاص بتكمل الخطوه اللي هنقولها بعد شويه. لو هو مش مديهولي اعمله بشكل راندم كده، اسميه الكارنت اي. طيب دلوقتي نحط الساين ازاي؟ الكارنت ده ماشي ازاي؟ كلوك وايز. واللوب ماشي ازاي؟ clockwise. قاعدة بتقول إذا كان الكرنت clockwise واللوب clockwise يعني الاتنين في نفس الدايركشن يبقى البوتنشال ديفرنس يبقى positive. وبعدين continue your calculation. 4.5 minus 0.5 equals 3 equal V plus 0.2. We can calculate V equal 1.8. 2.8. Okay? Again, it's too easy inshallah. Just you need to calculate more problems related to Kirchhoff first law or Kirchhoff second law. Let's revise or review what we said. The most important item to solve Kirchhoff second law, especially Kirchhoff second law, you have to pay attention about the signs of VB and IR in the right side. How we put the signs of VB. Okay? زي ما قلنا أهم حاجة اللوب والباتري. لو كان اللوب معدي من النيجاتيف للبوزيتيف يبقى بنحط الساين بوزيتيف. دايما بنحط الساين بتاع الأخير. لو اللوب معدي من النيجاتيف للبوزيتيف يبقى بنحط البوزيتيف. ولو كان اللوب من البوزيتيف للنيجاتيف يبقى نحط نيجاتيف. In English, if the loop passing from the negative side or terminal of the battery to the positive side, put the VB in positive. If the loop passing from positive to negative, put what? VB in negative side. What about the sign of the current or IR? The sign of the current of the potential difference. If the current passing through the circuit or through the branch with the same direction of the loop, the potential here positive and vice versa. Okay? In Arabic. لو كان الكرنت اللي في البرانش نفس الاتجاه بتاع اللوب يعني الاثنين سوا سوا مع بعض يبقى في الحالة دي الكرنت يبقى بوزيتيف وبالتالي يبقى اي ار بوزيتيف and vice versa. اوكي؟ جاست مطلوب منك تركز في خطوات الساين وتحل كتير. اهم حاجة تكوين الايكويشن في كيرشوف سكند لو. عشان كده يلا نحل مسألة تانية. مهما عدنا نقول عمرنا ما هنثبت اللي بنقوله الا من خلال بروبلمز. يلا نحل واحدة كمان. Kirchhoff second law. Second problem. A circuit consists of a cell of electromotive force 12 volt in series with a resistance 2 ohms connected to a resistor of 3 ohms in parallel with a resistor of resistance 6 ohm. Determine the total current drawn from the cell here means battery, and the potential difference across the 3 ohm resistors. Okay? Okay. Let's solve our problem. A circuit consists of a cell of electromotive force 12 volt. يبقى electromotive force here 12 volt. In series with a resistance 2 ohm connected to a resistors of resistance 3 ohm in parallel with a resistors of resistance 6 ohm. Determine, he wants what? The total current. He wants the total current and the potential difference across 3 ohm. After reading any problem in electricity, the first step you have to draw the circuit very well. A circuit consists of cell. يبقى we have now circuit battery 12 volt. 12 volt battery connected to a resistance of 2 ohms. 2 ohms resistance. Okay, then connected to another second resistance, 3 ohms. 3 ohms. And the last one in parallel with it, 6 ohm in parallel. 6 ohm. Okay, let's check. A circuit consists of cell electromotive force, 2 ohm in series, 3 ohm in parallel, and 6 ohm in parallel to term. Yeah. 2 ohm, 3 ohm in parallel, and 6 ohm. How he wants what? The total current that come from the battery. He wants I total. Then the potential difference across here. The potential difference here. He wants the potential difference across the resistance 3 ohm. How we calculate that? Pay attention. We can calculate that by 2 methods. By using the previous lessons, series and parallel connection, and we can apply Kirchhoff second law and the Kirchhoff first law. Okay, let's continue our solving. First, we can solve that problem by using series and parallel equations. 3 and ohm in parallel. Okay, R total equal 3 times 6 over 3 plus 6 in parallel, and the combination series with 2, so plus 2 equal 4. يبقى the total resistance of 2 and 3 and 6, all of them equal 4. How we calculate I total? I total equal VB over R total plus R small. So VB equal 12 over R total equal 4 plus what? 0, because there is no internal resistance. So 12 over 3, 4 equals 3 ampere. But the total current equals 3 ampere here. How we calculate the potential difference here? The potential difference across the resistance 3 ohm equal the potential difference across the battery, the electromotive force of the battery, minus I times 2. The potential difference that's taken by the resistance 2 ohm, as we solved it many times in the previous lessons. So the electromotive force equal 12 minus 3 times 2 equals 6. So 12 minus 6 equals 6 volts. We calculated that by using our previous lesson. Okay. We can calculate the same equation by using what? Kirchhoff first law and second law. How we calculate that? Okay, pay attention. My students, some students asked me before, Mr. Magdi, why Kirchhoff? Why Kirchhoff؟ يعني قال لي الخلاصة بتاعتكم سؤالكم هو كيرشوف ليه؟ هو كيرشوف ايه السبب ان يبقى فيه كيرشوف؟ يا جماعة كيرشوف ده يحل اي مسألة. حتى لو انت تقدر تحلها بالسيريس والبارل يحلها لك كيرشوف. كيرشوف دوت يعتبر انت لو انت بدأت تتمرس في كيرشوف هتتمنى ان كل الامتحان من اوله لاخره يبقى كيرشوف. يعني الخلاصة ان كيرشوف يحل المسائل اي سيركت سواء تتحل بطريقة السيريس والبارل زي اللي فاتت دي او تتحل بالقواعد بتاعه كيرشوف بس. تمام؟ لكن الكيرشوف بقى الاهميه القصوى في كيرشوف ايه؟ ان بعض البروبلمز، وهو ده اللي هناخدها ان شاء الله السيشن الجاي باذن الله تعالى. اجيب لكم بروبلمز لما نيجي نبص عليها كده غير اللي فاتت. اللي فاتت دي اتحلت بالسيريس والبارل ولا اروع، ولكن but we can solve it by using Kirchhoff equations. اوكي؟ يلا نبدا كده في كيرشوف. عندنا دلوقتي نرجع تاني بنفس التمرين بنفس الارقام بس هطبق عليها قواعد مين؟ قواعد كيرشوف. ارقامنا كانت كام؟ كانت 2 اومز، كانت 3 اومز، كانت 6 اومز، وعندي الباتري كانت 12، كانت 12 فولت. يلا بقى نطبق عليها قواعد كيرشوف ونجيب نفس الفاليوز. هتطول معانا الخطوات. عندي النود دوت، يلا بينا نسمي ده I1، ويلا بينا نسمي ده I2، وده I1 minus I2. يبقى at any node the current enter equals the current out. Okay, so then at the first loop just you make like that. At first loop summation VB, don't forget, equal summation IR, equal here 12, the loop from positive to negative يبقى here negative, and IR here I1 يبقى 2 times I1 in the current what? Down, but the loop, the current what? Anti-clockwise, but the loop clockwise, so the current opposite to the loop, so negative here. What else? I3 يبقى 3I2. What? The current to right while the loop left. The current opposite to the loop يبقى here negative. Classify, simplify, 12 equal negative 2I1 negative 3I2. Then the first equation. Then apply the same equation in the second loop. Number 1, make the loop like that. Number 2, summation VB equal summation IR equal. In that loop, pay attention, there is no battery, so summation VB here equals 0, while I2 equal I2 times 3, right, and the loop right also, so here positive, and 6 times I1 minus I2. What? Here clockwise, but clockwise, and here anti-clockwise in opposite direction, so negative. 0 equal 3I2 here in positive and 6 in negative, so minus 3I2. 3I what? 2. So minus 6I1. But we have now two equations. We have now two equations. One of them minus 12 equal minus 2I1 minus 2I1 minus 3I2. The second equation 0 equal minus 3I2 minus 2I2 minus 6I1. By solving the two equations together, we can get I1 equal 6, or what? Yeah, the same values of ampere here from the previous lesson of previous method, 3 ampere. Okay, and I2 equal what? Yeah, equal 2 ampere, and I3 equal 1 ampere. I3 here I mean I1 minus I2. يبقى الخلاصة يا جماعة، الخلاصة هو ده كيرشوف. الخلاصة هو ده كيرشوف. يبقى by using Kirchhoff يا جماعة we can solve any problems. Even that problem we can solve it by using series and parallel equations. Okay, again, by using Kirchhoff's second law we can solve any closed circuit. Even that circuit we can solve it by using series and parallel connections. And inshallah next session inshallah we will solve extra problems related to Kirchhoff first law and second law. Okay, but that problems or questions we cannot solve them by using what? Yeah, by using series and parallel connection. There is extra one. Okay, yeah. Look at the example number 3. What about that example? Yeah. Pay attention. Pay attention. Example 3. Pay attention about that circuit. That circuit we cannot, impossible to, we solve it by using series and parallel connection. So we can solve that equation by using Kirchhoff law. How we solve it? He wants us calculate the passing current through each resistors. How we solve that equation? Our problem now, we have that circuit. Okay, we have 12 volt battery, 3 ohms, 9 volt here, 1 ohm here, 2 ohm here, and current I1 here, current I2 here, current I3 equal I1 minus I2 according to Kirchhoff first law. Current enter I1 equal current out I2 and I3, so I3 equal I1 minus I2. Okay, let's continue. As usual, put the loop, anti-clockwise, clockwise rotation, whatever, if he didn't give you that. Sigma VB equal sigma IR. Okay, so in that circuit, 12 in what? Yes, in negative, because the loop from positive to negative, as we said before, equal IR, I2 times 1, I2 times 1, and what? 3 times I1, 3 times I1. What about the signs? Don't forget the signs. If the current with the loop, positive. If the current with, against, opposite to the loop, negative. The current here with the loop. Look at the current, look at the loop, together. So, in the same direction, I2 positive. What about I1? I1 down and the loop down also. With them, positive. يبقى minus 12 equal I2 plus 3I1. Equation number 1. And equation number 2 in the second one. Yeah, here. Make like that. Clockwise, anti-clockwise, whatever. Don't forget. But here, 9. What about 9? Negative. Why? Loop from positive to negative. So negative. I2 times 1. I2 times 1. I3 times 2. I3 times 2. But 2 times I3 here. I1 minus I2. In what? I2 with the loop. If the direction of the loop with the direction of the current here in positive, I2 positive. What about I3? I3 right, the loop left. Pay attention. If the current opposite to the loop, the current here negative. So we have now another equation. 9 equal I2 times 1, here I2 times 2, يبقى 3I2, and minus 2I1. We have now two equations. One equation, minus 12 equal I2 plus 3I1. The second one, minus 9, 3I2 minus 2I1. By solving them by any method, even you can calculate the calculator to know I1 equal what, I2 equal what. By substituting I3 you can say I1 minus I2. It's too easy inshallah. Just you have to form the equation. First one. Finally, Kirchhoff. It's too easy يا جماعة. Just pay attention about how you form the equation in a correct way. Pay attention about what, yes, pay attention about what the left side, what about the right side, what about the signs. Okay? From here to the next, inshallah, week, I want from you to revise what I study with you today, and I want from you to solve many questions related to series and direct connection and related to Kirchhoff first law and second law. Inshallah, بإذن الله تعالى. Next week we will solve extra problems related to Kirchhoff, and we will start our chapter, our new chapter, chapter 2 about magnetism. سعدت بيكم النهارده وارجو ان اكون فدتكم، و goodbye ان شاء الله to the next session ان شاء الله. Goodbye. Thank you.